Okay, good morning. Today we're going to be looking at the law of conservation of mass, but to get started, I need you to bubble last night's homework. Once you have it bubbled, please staple it together. There's 3 staplers over here, and put it into the box. Yes, sir.
Good morning, CJHS. Please stand for the pledge. The U.S. pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. The Texas pledge. Honor the Texas flag. I pledge allegiance to the United States, one state under God, one indivisible. Please walk
Okay, on number 3. Remember, you need a decimal, and it's in the 5th box. Decimal in the 5th box. Okay, I will draw it on the board. One, two, three, four, 5th box. You can get your chemical reactions booklet out on page 27. We're going to take some notes today, talk about what the law of conservation of mass is, and then you'll have an activity to do with your partner. Anybody else absent yesterday? Lane? We have 3 more minutes to get that bubbled and we're moving on.
What page is it on?
In the booklet, it's the blank page. I think it says modeling chemical formula at the top of it in your booklet. Modeling chemical formula. Okay, I'm going to put up the key for this in a moment, and then we are going to practice modeling the chemical formula again. You'll be using some of the colors. You'll be drawing 3 block models like we did the day before yesterday. Okay, so let's take a look at the key again. This is the key that we used. Now on that blank page, you have plenty of room to draw these. So first one I want everybody to draw. Please notice 2 NaOH. So at the top of that page there somewhere, draw 2 NaOH using the block diagrams. Remember, you're going to draw the little blocks. Now remember, is this 1 molecule or 2? 2. So you're going to have how many little models?
2.
You're going to have 2 little models. Now 1 molecule contains how many elements?
3.
3. So how many blocks do you need?
3.
You need 3. So everybody draw that. That's right. And then grab some colors and use the colors to color it. Na is brown, O is blue, and H is yellow. So on that page, everybody draw 2 NaOH. Perfect. Good job. That's it. Color now. Go ahead and label it. Yeah, you did. Okay. Okay. You have 1 NaOH. Now you need 2 of them. That's only 1 of them. See, that's NaOH. But you need 2 of them. Perfect. Exactly right. Two NaOH. Please model it. Block diagram. It's perfect, Andy. Good job. Dylan. Good, this is right. Label it as 2 NaOH. That's what it's done. Okay, the ones I'm seeing so far are all right. Matthew, that's right. So far, now you have to get the color right. Dalton, that's correct. That's correct. Okay, you need a brown, a blue, and a yellow. Brown, blue, and yellow. Okay, that is correct. Do you have your booklet? Can you get it out? Remember, you have to try. You have to try. Okay, I'm going to do it up on this board, and you check your answers. That's right, Catalina. That's right. Yes, sir. Okay. Yeah, that's it. Okay. 4, 2, NaOH. First thing you ask yourself, how many molecules? There are 2. That means you need 2 little models. So let me find them. Okay. We need 2 little models. And we need 3 elements. We need an Na, we need an O, and we need an H. Okay? I've got to have a better one. Go ahead with the sharpener. But that's just one molecule. We needed two, so I had to draw another one. And then you just had to color those. Hydrogen was yellow. Sodium is brown. And oxygen was blue. And that's the way yours should have looked. Does everybody see that? Okay. Do the next one. FeCl2. Write down the chemical formula and then create the model. FeCl2. It's Cl2, chlorine. They're together. Okay, NFeCl2, Bren, how many molecules are there? FeCl2, molecules. Yeah. Okay, listen, y'all are not still understanding this. Everybody listen so you learn. The number in front, the coefficient, tells you the number of molecules. What's in front here? But it should, a 1. So how many molecules are there? There's 1. So how many models should you draw? Just 1. How many elements are here? 2. So how many blocks do you need? You need 2. So let me draw this one. We have 2 blocks. There's an Fe. Excuse me, we have 3 blocks because of this subscript. That's right. I'm sorry. Because of the subscript, we need 2 Cls. Chlorine is green. And iron is red. And that's what your model should have looked like. Okay, questions? Gracie, we're going to do the next one. 2H2O2. How many molecules? There are 2 molecules, so we need 2 block diagrams. We have 2 hydrogen and 2 oxygen per molecule. So how many blocks do we need?
4.
We need 4. So we need 2 sets of 4 blocks. Let's draw, everybody draw that one. Now you're getting the hang of it, right? Perfect. 2 bottles. No, with 4 each. 4 each. Perfect. Yes. Perfect. You're getting the hang of it? Okay. Names up there, 2 and 8. You can use them. label them. 2NaOH, FeCl2, label them these. You label these so you know what they are. Okay, today with the law of conservation of mass, we're going to take this one step further. Today you're not going to be actually drawing the models again, but you needed to be able to visualize what is going on here. The one thing you absolutely have to be able to do in order to understand the law of conservation of mass is be able to count the atoms in chemical formula. Okay? So, flip to the next page in your booklet when you get that covered. And we're going to take a look at what is the law of conservation of mass. Okay? It is a law. That means it is always applicable. Okay? For what we know today. And when something becomes a law, like the law of gravity or the laws of motion, that just means that there is multiple and numerous amounts of data showing this happens every single time. Okay? So that's what makes a law, and it's not just a hypothesis anymore. Okay? Now, what is the law of conservation of mass? Please follow along, fill in the red words as we go through. First of all, in any ordinary chemical reaction, when chemical reactions occur, matter is not created or destroyed. Matter itself is never created or destroyed. The only thing that happens is the atoms get rearranged. So if you start with 10 atoms, how many atoms are you going to have after the chemical reaction? You're going to have 10. Because no new ones are created, and none of those 10 are ever destroyed. Okay? So if you start off with 1 million atoms, how many are you going to have after the reaction? You're going to have 1 million. Okay? So they are never created or destroyed. What does that mean? That means that chemical reactions satisfy the law of conservation of mass. In other words, the mass of the reactants must equal the mass of the products. So if you could take your reactants and measure their mass, mix them together and let a chemical reaction occur, whatever you're left with after that chemical reaction should have the same mass as the reactants. And it's always true in every case. Okay? Chemical. Now, what do we use to represent a chemical reaction on paper? What is it called? Not just the formula, but the whole, with the plus. Yes, we represent chemical reactions with chemical equations. Now, in order for these chemical reactions to follow the law of conservation of mass, even our chemical equations must be balanced. It's called being balanced. That's the reason that arrow also means equal. Okay? So all of those little reactants yield the product, but they also equal the product. Okay? So, for example, if this right here underwent a chemical reaction, these three elements are going to break apart and be separate. Okay? They're going to break apart. We talked about those bonds being broken, right? And then guess what they can do? They can come together with something new that was in a different reactant. But whatever you started with on the reactant side, those three are going to be on the product side somewhere. They're going to be there somewhere. Okay, a balanced chemical equation, what does it involve? Okay, first of all, it has the same number of each type of atom on each side of the equation. So, for example, on this one, we have aluminum and sulfur as our reactants. And we have aluminum and sulfur as our product. So that is correct, right? How many aluminum do we have on this side?
One.
One. How many do we have on this side?
Two.
Is that equal?
No.
So would you consider that being balanced?
No.
That one is not balanced. And it's called being unbalanced. Please circle the AL and circle the AL2 so that you can see that those are not the same, and that's called being unbalanced. Now, in order to make this balanced, you know, Al2SO3 is some substance. Okay? It's aluminum sulfide is what it's called. And the 2 and the 3 in aluminum sulfide cannot change, because if this 2 and 3 changes, would we have aluminum sulfide? No, we would have something else. So down here, Al2SO3, in order to make this a balanced equation, what did I have to do? What did I add?
Add another one.
Add another molecule. That's exactly right. We added a coefficient. So if, and we will do this next week, you're asked to actually balance it if it's not, the only thing you can ever add are coefficients. You can only add coefficients. So I had to add a 2 in front of the aluminum, so I had 2. The subscripts can never change. You couldn't add a subscript here to make it balanced. You never add subscripts. You never subtract subscripts. Okay, because that makes it a whole new substance if you do. To keep the same substance, we have to add a coefficient, because that's just saying now we have 2 of that substance. We didn't change it. That's the reason it was important to understand that you have 2 molecules of something instead of 1. So the second one, we have 2 aluminum, and we have 3 sulfur in the reactants. Do we have 2 and 3 in the products?
Yes.
That is called being balanced. Balanced. Okay, determining if a chemical equation is balanced or not. You're going to have to be able to do this. Okay, chemical equations are balanced by changing coefficients only, never by changing subscripts. You absolutely will never change subscript. You can only add coefficients to the front to change the number of molecules. You count the number of atoms on each side of the element on the reactant side. So this is the reason why counting the atoms, learning how to do that was so important. Then you count the number of atoms of each element on the product side. If they're equal, the equation is balanced. If they're unequal, then the equation is unbalanced. So as you're writing that stuff down, you're reading that to yourself. If they're equal, it's balanced. Think of it as a seesaw. If you're sitting on a seesaw and there's nobody on the other end, is it going to be balanced?
Nope.
You're going to hit the ground, aren't you? But if you had a friend that weighed exactly the same as you, what is the seesaw going to do? It's going to equal out in the middle. Okay? And that's what this is like. You have to have equal mass on either side for it to balance. If there's not equal mass, is it going to balance? No. Okay, it's not going to balance. Okay, let's see how this works. In chemical equation, Na plus AlCl3 yields NaCl plus aluminum. Somebody tell me, what are the reactants there?
Na plus Al.
Very good. Everybody write that down in the box. Those are our reactants. Our products are NaCl plus Al. Okay, now, in order to determine if this is balanced or not, we have to count the number of atoms in the reactants. Okay, so I'm going to list all the elements in our reactants in that data table below that. We have sodium. Oh, first of all, I'm going to add the subscripts here. So NA needs a subscript. AL, does it need a subscript? Yes, it does. We need a coefficient here, a coefficient here, subscript here, subscript there, coefficient, coefficient. So that's one of the things you're going to have to do also. Remember to add those. Now I can list them. On the reactant side, we have Na, Al, and Cl. Somebody tell me, how many NAs are there?
1.
Very good. How many ALs? 1. How many CLs? 3. Okay. Now remember, there is a plus here, so this is two different substances, but it doesn't matter. You have to count them all.
And they all have to be the same on the product side.
Right. So now we're going to check if they're the same. So we're going to. How many NAs do we have here? How many CLs? And how many ALs? Are they the same? They're not. So is this equation balanced? It is not. So on this side, the Na is 1, the Cl is 1, and the Al is 1. Okay. Now, a good habit to get into when you're doing this, take the elements in your reactants here and list them in order. Okay, that you see them. And then immediately take these and write them in the same order on this side so that they're easily compared. You can look straight across. If we had written them down here, would they have been in the same order? It could have been a little confusing. So write them down on this side in that order, and then just take it from here and move it there. Now, you might get to the point where you don't have to write down this multiplication. You can just do the total of each element. That's up to you, whether you want to do the show your multiplication or not. Okay? Totally up to you. And again, this one, because which one is not equal? Chlorines are not equal. This is unbalanced. Is it balanced? No. There are 3 chlorine atoms in the reactants and only 1 in the product. So this is not balanced. Now later, next week, we're going to learn how to balance it then. Okay, we're going to learn how to balance it. To get 3 chlorines over here, I'm just going to talk about it real quick. How can I get 3 chlorines here? How can I make this 3 of them? What would have to change?
We have to have 3 bonds.
The coefficient. What does this have to become?
3.
A 3. But then what is that going to make the Na? 3 also. So we're going to have to go over here and make this a 3. And then it's balanced. You only do it by changing coefficients, and we'll be doing that next week. Okay, let's take a look at the second example. This one you're going to do, and I'm going to walk around and check. Okay? List your reactants, then list your products, count your reactants, count your products, and determine if it's balanced or not. Do the multiplication in your head if you want. Yeah. Yes, so 2 times 1 is 2. Yes, these are all. So is it balanced or not? How many of those CLs do you have? 2 doesn't go all the way across because there's a plus sign. Yeah. Okay, listen, remember, and I see people doing this multiple times. When, everybody look up at the screen. Put your pencil down, please. Up at the screen here. This plus sign is like a divider between this substance and this. This 2 right here does not go with the chlorine. Chlorine should have a what in front of it? A 1. So there is only 2 chlorines. So be careful with that. Yeah. Okay, I'm going to pull up the answer here. Everybody check your answer. The ones I've seen are all right. Once I've mentioned to you about being careful with the coefficients. So here, 2KBr plus Cl2 is the reactant. 2KCl plus Br2 is the product. We add our subscripts. Potassium gets 1. Bromine gets 1. There's a coefficient of 1 in front of the Cl. There's a subscript of 1, and then there's a coefficient of 1 in front of the Br. Yes, sir. Yeah, well, anytime there's an element by itself that's, this, like this isn't here because that's a whole different substance. If it's just Cl2 by itself, it needs a 1 in front of it. It's just its own separate substance. That plus sign divides the substances. That's meaning we're mixing 2 different things. This substance plus this substance. They're not part of the same substance. And that's the reason they both, there's only 1 molecule of that. There's how many molecules of this one? There's 2 molecules here. How many molecules are here? 2. And how many here? 1. Okay? So that's the reason those coefficients need to be here. Then you list your elements. KBr, BrCl, and I'm going to do that in the same order on that side. There is 2, 2, and 2, 2, 2, and 2. So this is balanced. The atoms on the reactant side equal the atoms on the product side. Okay? Okay, you'll have 8 of these to do. You may get with the partner. If you don't finish it today, you will have some time in class on Monday to finish it. It is not homework.
I'll explain. What if I put its balance and the products and reactants are equal?
That's fine. There's only 8 of them. Jace, you can move to be with the partner somewhere as long as y'all work. Okay? Okay, y'all need to work on this. Yes. Because it's its own substance.
I'll work it on.
Now, there is still listed for you, so you just have to have but I think there's 2 here. 2, but you also have 2 there.
Section or class.
It's on second period. H's are 3 here and 4 there, so they're not the same. So is it balanced or not? Is this balanced equation? Okay, explain it. Why? What's not equal? Because you have 2 there and 2 there. to get at least 4 of these done today. Okay, let me I'm going to do the first one on the board over here, and I want to do the shortcut method. I want everybody to watch up here, and this is the way I suggest that you do it. Otherwise, you're going to make some silly mistakes like I see people doing. Okay? Okay, so here, what I suggest again is to put the subscripts and the coefficients where you need them, and then shortcut method. Everybody look up here, please. Okay. 1 times 1 is, 1 times 3 is,
3.
2 times 2 is,
4.
1 times 1,
1.
1 times 2,
2.
2 times 2,
4.
2 times 1.
2.
Okay, now you have the numbers that you need up there, and then it's just a matter of listing them. C equals 1, H equals 3, O equals 4. On this side, we're going to do the same order, C, H, O. Here we have how many C's? 1. How many O's? 2. Plus, how many H's? But we have how many O's over here yet?
2.
So you have to add that there for a total of 4 O's. Okay, so it was unbalanced because the H's are not the same. Some of you forgot to add these O's together. There is a plus sign here. Make sure you're adding them together. have to count. Okay, you don't have to count
On
it.
energy, you don't have to count it?
No. No, just keep it. Yes, sir. Yes. If you're finished with that, go ahead and fold it in half and put it in your warm-up folder in your journal till tomorrow, till Monday. You can work till the bell rings. You are.
around 80.
Yeah, some of them are pretty complicated.
I'm doing like heroic stuff, cloud, Vicky Cloud.